In this question, we are given a diagram containing 3 resistors in series, and we're told that R1 is 10 ohms and R2 15 ohms, R3 is 20 ohm, and the current is 0.5 amperes. And we ask at what rate is heat being generated in this resistor. For heat to generate there must be power, so we need to calculate the power. That's what we're asked to do, and we have that power is equal to I squared R. So there are 2 ways in which we can solve this question. We can decide to calculate the individual power and sum it up, and in the second part we can as well decide to find the equivalent resistance and calculate the power directly, and we'll do the 2 together. So the first, we need to calculate the individual power. So P1 is equal to, I is given as 0.5, and R for R1 is 10, 0.5 squared multiplied by 10, and this is same thing as 0.5 squared is 0.25 multiplied by 10, and this is equal to 10 multiplied by 0.25 will give us 2.5 watts. So for the power generated in the second resistor, power in the second resistor will be equal to 0.25 square, 0.5 square multiplied by this the resistance 2 is 15, which is equal to 0.25 multiplied by 15, and that will be 3.75 watts. So, and P3 is equal to 0.5 square multiplied by the resistor. The resistor is 20, which is equal to 0.25 multiplied by 20, and that will be equal to 5 watts. So at this point we can say that the total power will be equal to P1 plus P2 plus P3, and this is equal to P1 is 2.5 plus 3.75 plus 5, and this will be equal to 11.25 watts, and this option is the correct. So if we decide to solve it using a different approach, we can use this different approach, which is calculating the equivalent resistance. So since the 3 resistors are in series, then we have the equivalent resistor to be equal to R1 plus R2 plus R3, and this is equal to R1 is given as 10, R2 is given as 15, and R3 is given as 20, and this will be equal to 45 ohms. So having gotten the equivalent resistor to be this, and we have this formula, I will make use of this formula. So we have P to be equal to I squared. I is 0.25, sorry, 0.5 rather, multiplied by 45. So we have this to be 0.5 squared is 0.25 multiplied by 45, and this will give us 11.25 watts, and it's the same thing as the first solution we got. And at this point we can infer that 11.25 watts is the right answer.